So here we are going to discuss about the third important and most precious resource ever on earth because of what we are existing on earth called water. So let's start. Water resource is renewable is what we have to understand at the outset, because in chapter 1 as we studied water renewable resources, everything that can be renewed in a small amount of time. So how does water get renewed, right? There is a certain cycle in nature which we all know as the water cycle, which is evaporation into the air from the oceans, then the precipitation from the clouds as snow or hailstone or sleet or rain, right? These are the forms of precipitation. At the end, they go down to certain sources like rivers or lakes, and from those surface runoff, they go back to the oceans, and then the water vapor goes up into the clouds again. So this particular cycle you all have studied, and as we all know, it is called as the rain cycle or the water cycle. But on the right hand side, I want also to pay attention on the drinking water cycle today, because though we know that this cycle is going on, this one is pulling a lot than the current natural water cycle can deliver. Okay, so hence we are going to study about the source or any kind of storage of water, maybe artificially constructed like how there a tank anywhere. From there, there is a water system, maybe a purification kind of a setup. From there, it goes to the overhead tanks of big, thousands and 10,000 liters of capacity in the urban areas. From there, there is a particular canal or maybe pipelines are laid down from which it is provided to every household. Okay, so let us assume that these are household A, B, and C, and one particular person who does not live in a house, right? We know that those are the underprivileged sections of the community who might not be able to receive regular water supply from pipelines. So why are we studying them also while we are studying this resource? Because they are also one of the major consumers, right? As the population is growing, they also are consuming this resource equally. So we have to consider them also. So this is the pipeline. Then after the pipeline, the domestic treated drainage water, sewage water goes to another pipeline, and gets collected in the wastewater plant. From there, it goes into the discharge tank, from there to the aquifer, and then they try to recycle it, purify it, etc., and provide it to you for regular purposes. So, how can we claim that this is the drinking water cycle or consumer water cycle? Is because this is how we have been seeing water in our daily lives, day-to-day lives, that the government is providing us with so and so capacity of water, and we are paying for them at the end of the year, maybe everywhere. So, the moot point is, still there is a particular scarcity of water always. Some seasons, some summer, we will face that there's no light and we are running for water, etc. So though it is adding more, it is not enough, is the thing that we understood, that this is the human cycle, this is the natural cycle, and this is greater than this. Okay, so much of the water on earth, naturally, if we go to see, is arrested in the glaciers away from direct use. The fresh water, that is what? The drinking water, if we go to see. And 70% of this fresh water also is like in the glaciers, which is the most precious element on earth. 2.7% of the entire 70% on earth is actual fresh water, only 1% of which is directly available to us on maybe plains or plateaus, in rivers or in lakes. Okay, so now we understand that one of the main reasons for scarcity is that we are consuming more than what we are getting. Number one reason. And number two is that the water cycle is going on, but the actual supply of fresh water in nature is limited. Okay, it's not, you know, uh, what do we say? It's not an inexhaustible source of energy. It's like it'll be limited. Or out of the 70%, only 2.7% is fresh water and 1% is fit for drinking directly. We will talk about these ABC households again, but right now let us move on to the uses and sources of water. We all know about all of these mostly. If not, few of you who have not maybe visited rural side, I will just like to tell you that this is a canal which is planned near a dam maybe. This is a well, this is a bore pump or a hand pump, and this is the tap that we all get our waters from. And these are how we are using the water, right? Maybe for watering, for bathing, for cooking, for drinking, for cleaning your own self, for washing the utensils, etc. And so we all know that sources itne hain, to uses bhi humne, we have found equal number of maybe uses, and that is how we are using water at almost all the places and walks in our life. Now moving to the problems in accessing, which is why we were talking about that label of ABC. Uh, this particular person who does not have a pipeline, as I said, some poor person will have a shortage and problem in accessing water, maybe because of a natural geography also. Like for example, the Saurashtra region in Gujarat, which is a rain shadow region and receives very scanty rainfall. It's a part of the desert, so obviously there is shortage. However, more than the natural things, what has happened is these people have a weekly market, maybe the water market, and they try to access water through that. Moving to the climatic zone, what could be the problems due to climate or the changes in climate? Okay, so seasonal variations or lack of precipitation one year, the next year you have floods, and the next year again there's some shortage and there's less rain, and again you have droughts. So these seasonal variations are very unpredictable, and this all happens when the balance in the ecosystem is changing constantly, maybe due to human activities or evolution, whatever is the reason. Now the main cause, however, as we can chart out, though there are natural factors, the main cause is the overuse or the wastage of water which we have received. How much ever we are getting, we are not satisfied, we are always asking for more, and that is what is the uh, main thing which is causing a stress on this resource. Now, how does contamination of water source happen is a part of our study. And we are going to see three main reasons here. One is the sewage, the domestic sewage that we do not treat or partially treat. And in industries, then again, they do not maybe treat the waste and let it out in the rivers directly. That is one cause, untreated sewage. Second is the industrial effluent or the byproducts of whatever manufacturing has happened after that, maybe in terms of water vapor or I mean in gaseous form or in liquid form. The chemical waste and the industrial let out does matter. River Yamuna is the best example that effluents have really declined the quality of water in the river. Agriculture. Now, how can agriculture pollute? Especially about water, we have to note that there are certain chemical fertilizers which are used for increasing the crop harvest, and that is the reason why the sources of water get polluted. And also by dumping of certain things that are used in agriculture just for the sake of it. They do not take care of how the crop is treated or whether it is clean or not. So the flow of water is disrupted, the quality goes down, etc. So these are the main problems in accessing. First is the climatic reason. There could be one or two, and the main cause is overexploitation, and the most important is contamination or pollution of water sources. This is an informational slide, actually not part of the study in 8th standard, but today if we have any value added questions, we should know that by 2030, the demand which is predicted is way higher than the actual supply or water sources, the rivers or ponds that we have in India. So surplus water will be present only in part of Ladakh and Northeast India. Apart from that, we have a severe water crisis in many of the states. Okay, and in the other ones which are in dark blue, they will have a moderate level of crisis. That is, the supply will be almost equal to the demand. And places which are going to have severe problem, there the supply will not be enough and the demand will be very high. Okay. Also, we have to note that as school children, mostly under 14 of age, the children do suffer due to bad quality of water. They suffer from skeletal and dental problems and fluorosis. Also, there are almost 73 million working days that are lost, 443 million school days that are lost because there are infections through water or there are bacterial diseases through water, which we all know of. So how to conserve? There are two approaches. First one are the traditional ways that we are already using, and the other one, the modern one, we have seen a few examples while we discussed in the class about Internet of Things, how they're using connections and smart meters to get away with the actual calculation, how much are we using, how much should we use, etc. So those comparisons can be made and you could be learning a lot and saving a lot through such initiatives. So these are the 5 startups that you can read later. Right now in the slide, we're going to study about the traditional methods, which are rainwater harvesting. In the worksheet, I have also given a particular diagram for it where you can see that any water that is falling on your roof is not getting wasted. It will be carried through a pipe into a storage, any kind of small aquifer or tank that you've built, and it will be stored there so that in terms of wastewater, we can use it rather than using the tap water. Okay, that is the practice of rainwater harvesting. Now, leakages in canals, pipelines, and taps are very, very crucial. Though we think it's a minor thing, about 1200 liters of water can get wasted in a year if you have one leaking tap in the house, right? So this is one thing. That is why we should act on it. We should not let this happen. Over pumping and using motors, right? Motors as in some electrical machines to pump the water whenever there is no supply of water. We are trying to pump the groundwater and store it in the tank. So that also should be minimized or at least balanced, not overusing it. And the last approach is we have to save first and use later. That is, while we're using, are we saving also? Just ask this question and then start using water, right? There are a few things or initiatives that the businesses or the governments or industries can take, agricultural industries can take, like irrigation methods, new irrigation methods like drip and sprinkler, which are very useful in dry regions. Wastewater treatment should be made mandatory for all industries so that they don't pollute. Dams should be well maintained so that we are not losing water from there. Supply must be regular. The water supply that we get should be regular and not in excess. And water meters and taxes also have to be revised and changed from time to time so that this kind of Saurashtra type of a scene does not happen in any of the urban settings in India. Few again out of the box ways to save water. There is something called a wonder food which saves water even while growing, and after growing it is a powerhouse. It will contain a lot of water. So these are a few examples of it. Maybe cauliflowers or carrots or bananas, etc. We are also talking of a particular area where there's no electricity to pump the water. We can have solar water pumps, and it will take out lesser and equal or good amount of water from the ground table and not over pump it. Okay, so this is one solution which is very, very valuable today. And the last one, your own daily usage. An urban Indian, as your textbook is saying, uses about 150 liters of water every day. And if we have to minimize it to 50 liters, what all can we do? These are a few suggestions. Okay, one is about uh, using less water in dishwashing, or maybe house cleaning or laundry, right? Even using showers should be minimized, and more usage of buckets or flushing should be very, very proportionate, not overdoing it, etc. So such initiatives are small ones, but day in, day out, every drop will count, and we will save ourselves from a day zero of water resource.